Okay, let's go over the handout for trig function application. It says Miss O'Leary's cat is stuck in her backyard tree. A fireman positions a ladder against the tree branch and rescues the cat. The ladder was extended 22 feet and made an angle of 62 degrees with the ground. What was the cat's vertical height in the tree? So with our referenced angle of 62, we have opposite and we have the hypotenuse. So opposite over hypotenuse is the trig function sine. So the sine of 62 degrees is equal to x over 22 feet. We're going to cross multiply. We get x is equal to 22 times sine of 62 degrees. X is isolated. So in our calculator, we're going to say 22 times the sine of 62, and we get 19.4. So 19.4, and then if we want to round it to a whole number, 19 feet. Number 2, from the top of a barn, a pigeon spies a pile of birdseed on the ground. The angle of depression of the seed is 38. So again, the angle of depression, the bird's looking out, and then he looks down at the seed, and this is 38 degrees. The height of the barn is 28 feet. We want to know the distance from the pigeon to the feed, so we're looking for this hypotenuse. We can use the angle of depression and subtract it from 90 to get this inside angle as a reference angle, or I'm going to just say that we know this angle and this angle are congruent because they are alternate interior angles. So this little diagram here. So those are alternate interior, and that's what this angle of depression is. So we know this is 38 degrees. So this is going to be my reference angle. So I know the opposite, and I know hypotenuse. So that is sine. So the sine of 38 degrees is equal to 28 over x. We're going to cross multiply. Put our x out front. We're going to isolate x by dividing each side by the sine of 38. We have x is equal to 28 divided by the sine of 38 degrees. So I'm going to use my n over d feature, 28 in my numerator, sine 38. And we get 45.5, or if we rounded, we could round up to 46, but since it's about 45 and a half, I'm just going to leave it as 45 and a half feet. Number 3, a tree casts a shadow that is 26 feet long. The angle of elevation of the sun is 68. So remember, elevation is looking up, and it's inside the triangle, so that's 68 degrees. We want to know the height of the tree, so we're looking for x. So the angle of reference is going to be opposite and adjacent. That's going to be tangent. So we have the tangent of 68 degrees is equal to the opposite, x, over the adjacent, which is 26. We're going to cross multiply. X is isolated, so we're simply going to say 26 times the tangent of 68. We get 64.35, so I'll round that to 4, and this again is still feet. 4, a plane takes off from LAX airport and ascends for a distance of 3,200 feet. If the plane traveled 2,400 feet horizontally, find the plane's angle of elevation. So we're finding an angle. So remember, we're going to use the inverse trig functions. So we have the adjacent and we have hypotenuse. So that gives me, so if we have adjacent hypotenuse, that is cosine. So the cosine of some measurement is equal to 2400 over 3200. We're going to use the inverse. Let's choose a different color now. We're going to do the inverse of cosine on both sides. That isolates x. So in my calculator, I'm going to do second cosine, the n over d feature, 2400 over 3200, and enter. We get about 41.4. So if we round to the nearest degree, x is 41 degrees. Number 5, when attempting to stop at a stop sign on an icy road, Jerome slid through the intersection to a nearby 15-foot telephone pole. The angle of elevation of the telephone pole from the bottom of the stop sign was 70 degrees. How far did Jerome's car slide from the stop sign to the telephone pole? So our angle, our reference angle is 70 degrees. So we know the opposite and we know adjacent. So opposite over adjacent is tangent. So the tangent of 70 degrees is equal to 15 over some distance. We're going to cross multiply. We are going to isolate x by dividing both sides by tangent 70. So x is going to be equal to 15 over tangent of 70. So n over d button. So we have 15, and then my denominator is tangent 70. We get 5.5 about. So x is about 5.5 feet. From the top of the lighthouse, the angle of depression of a speedboat is 23 degrees. The boat is 100 meters from the base of the lighthouse. Find the distance from the top of the lighthouse to the boat. So we're looking for the hypotenuse. So my reference angle, this is 23. This is also 23, alternate interior. So I know my adjacent and we're looking for the hypotenuse. So adjacent and hypotenuse is cosine. So the cosine is of 23 degrees is equal to 100 meters over x. Cross multiply. Divide each side by cosine of 23. X is going to be equal to 100 over cosine 23. So n over d, 100 in my numerator, cosine 23 in my denominator, we get 108.6. And this is meters. Always put your units. From the top of a post, Felix the cat sees a mouse across a small pond. The pond is 10 feet tall. The post is 10 feet tall, and the width of the pond is 12 feet. Find the angle of elevation of the top of the post from the mouse's location. So right here, we're looking for this angle. So we'll be finding an angle measurement. So we'll use the inverse. So we know opposite and adjacent, that's going to be tangent. So the tangent of some angle measurement is equal to 10 over 12. We're going to take the inverse of tangent on both sides. And x is equal to the inverse of tangent times 10 over 12. So we're going to do second tan n over d, 10 over 12. And that gives us about 39.8. So if we wanted to round to the nearest degree, we would say 40 degrees. 8. Find the ground. From the ground, a rocket is fired vertically into the air. A camera on the ground is 25 feet from the launch point, is angled at 74 with the horizontal in the direction of the rocket. At this angle, how high would the rocket have traveled when its nose appears in the camera's window? So we have a camera, 74 degrees. Let's get a different color. It's hard to see on that white. 74 degrees. A camera is on the ground 25 feet from the launch point. So from here to here, this is 25 feet. We want to know how high would the rocket be. So this right here, we're looking for this. How high would this be when the camera gets when the nose of the rocket appears in the camera? So let's set this up. Our reference angle, we have opposite and we have adjacent. That's going to be tangent. The tangent of 74 degrees is equal to x over 25. We're going to cross multiply. We can see that x is isolated already. So straight to the calculator, 25 times tangent of 74 degrees is about 87.2. And this is feet. Number 9, a car travels along a hill inclined 12 degrees with a horizontal for a distance of 1,200 feet. What is the horizontal distance? So this is 1,200 feet, and we want to know the horizontal, the straight across, the horizontal distance the car traveled. So here's our reference angle. So this is adjacent, and this is hypotenuse, so that's cosine. The cosine of 12 degrees is equal to x over 1,200. We notice, again, x is isolated, so straight to the calculator. 1,200 times the cosine of 12 degrees is 173.8, and this is feet. Number 10, from the top of the Ferris wheel, the angle of depression of your friend on the ground is 61 degrees. If your friend is standing 30 feet from the foot of the ride, so from here to here is 30 feet. How tall is the Ferris wheel? So we're looking for how tall. So we have 61 is the angle of depression. We know this inside angle is 61 degrees as well, alternate interior angles. So we have opposite and we have adjacent, so that's going to be tangent. So the tangent of 61 degrees is equal to x over 30, cross multiply. X is isolated already, so straight to the calculator, 30 times tangent 61 gives us 54.1, and this is feet.